Welcome to Honors Geometry 7.1b, the Pythagorean Theorem. Probably the most important theorem in all of geometry, and probably one of the top 5 mathematical concepts in all of geometry, with the amount of mathematics that it produced. And now, without further ado, the scarecrow.
Sum of the square root of any two sides of an isosceles triangle is equal to the square root of the remaining side.
That's right, folks. He misquoted the Pythagorean theorem, and what he quoted was not true at all. In some cases it may be true, but in other cases not at all. Here is the actual Pythagorean theorem. In any right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Alright, so what you have going here is you need to know what a hypotenuse. Wow, that was a great job of circling that, wasn't it? You have to know what a hypotenuse is. And you know what? Since we did proving triangles congruent with hypotenuse leg, remember that it is the side that's opposite the right angle. So C would be the hypotenuse. The legs are the two sides of the right triangle that form the right angle. Those are the legs. So, according to this picture here, using the words of the Pythagorean theorem, our equation should be, okay, the square of the length of the hypotenuse. The length of the hypotenuse squared is equal to the sum. What are you adding together? The square of the sum of the squares of the lengths of the legs. So that would be a squared plus b squared. And I know that elsewhere in life you learned it as a squared plus b squared equals c squared, but I'm telling you right now that it's going to be better in section 7.2 if you do it this way. Just go ahead and nod your head and say, sure, we'll do it that way, because when we get to 7.2 in the Pythagorean converse, it will actually make more sense if we write it this way, just like the words say on the theorem. So let's go ahead and put the Pythagorean theorem into practice. Are you ready? I should hope so. Your equation is hypotenuse squared, 10 squared equals x squared plus 8 squared. 10 squared, 10 times 10. Okay, 8 squared, 64. Subtract 64 from both sides. 100 minus 64 is 36. 36 equals x squared. We'll take the square root. And plus or minus 6 equals x. However, because we're talking about the length of a triangle, we'll forget that negative root, so that missing leg is 6. Moving right along. Okay, hypotenuse squared equals the sum of the two legs squared. X squared equals 16 plus 16. X squared equals 32. Take square root of both sides. And x equals, and hey, I don't know if your book or whatever's going to ask you. If they ask for a decimal rounded to the nearest tenth, 5.6. And then if they ask you to simplify that, x would be 4 root 2, because root 32 is root 16 times root 2. I'm not sure which one of these they're going to ask you for. Okay? I just don't even know. This might be 5.7 now that I think about it. Yeah, I think that is 5.7. Yeah, 5.7. Alright, let's move along. Okay. Your equation is 17 squared equals x squared plus 14 squared. 289 equals x squared plus 196. Subtract 196 from both sides. And subtract 196, that'd be 93 equals x squared. Take square root of both sides. That missing leg is, hold on a minute, according to my calculator, 9.6 is approximately how big x is. Okay. Whoa, wait, whoa, where's the hypotenuse? Oh, here's the right angle. Oh yeah, opposite that. So our equation, hey, stop that now. I don't know what's going on there, do you? Nope. 25 squared equals x squared plus 24 squared. 625 equals x squared plus 576. Subtract 576 from both sides, and you get 49. Take square root of both sides, and 7 equals x. That missing side is a 7. Hey, when all three sides of a triangle are whole numbers, it's called a Pythagorean triple because they're all whole numbers. We'll talk about more about those in class tomorrow with Pythagorean triples. Alright, so that's how you use the Pythagorean theorem. C squared equals a squared plus b squared. In any right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Not what Mr. Scarecrow said. This will conclude Honors Geometry 7.1b, the Pythagorean Theorem.